Okay, let's continue to work on learning target number 2. So first thing, I guess I should preface, I'm going to be jumping in and out of the screen just so I can see where we're at timing wise. So like when I enlarge it and then bring it back down, that's what I'm doing. So first thing, we've talked about vector addition and how we can put the tail of one vector onto the tip of the other, and then we get a resultant vector there. Okay, this is exactly the same as if you broke them up into their components and added those together. So like this addition or this resultant of these two is equal to the vector A, its x component, plus B and its x component. And then you can also look at that with the y components as well. Okay. So it's basically saying if I were to take this vector here, and we'll call it vector A. Well, vector A is just the components of its x and its y, right? Like A vector is equal to AX vector plus AY vector. And I could draw those out. I could show that we have an AX vector plus an AY vector, and that will result in the overall vector of A. So now I'm saying I could add these two and break them into their components, and that would tell me my resultant from that. Okay, two vectors, two weights pulling on an object in different directions. Add the two vectors A and B using their component vectors. Okay, so it's saying we have a weight that's pulling for the A vector, and then we have a weight that's pulling for the B vector, and we want to see where the resultant is of those two if we added those two together. Okay, so let's start by recognizing and solving our AX and our AY. Okay, so we have an angle of 30 here. Oh, and that reminds me, we're going to, for the moment, concentrate on the concepts and the math, and then at the very end I'll talk to you about Sig Figs. Okay, so we have an angle of 30 here, and we have opposite from that angle would be A sub y, and then adjacent to that angle would be A sub x. Okay, so we need to go back and remind ourselves about sine is equal to opposite over adjacent. Sorry, one second, my pen's running out. There we go. Sine is equal to opposite over hypotenuse. Cosine is adjacent over hypotenuse. And then tangent is equal to opposite over adjacent. Okay, so if we want to take the sine of 30 here, so we're going to go sine 30, and we talked about this, remember, we addressed this last video. Okay, so if we want to go sine of 30, well, that's going to equal opposite, which is A sub y, divided by hypotenuse, which is just A. Okay, and we know A has a magnitude of 42 grams. So now I can solve for A sub y, and so A sub y is equal to 42 grams sine 30. Okay. And that is, grab the calculator, 42 times by the sine of 30. Make sure that you're in degree mode in your calculator. That would be 21 grams. Okay. Now that's the y component, but we want the x component and see how it's adjacent. And so when we come here, we're going to use cosine now because we want that adjacent. And so it turns out that A sub x is going to equal 42 grams cosine 30. I didn't go through that one step by step, So if you want a reminder of how I achieved that, watch the day's video before this one, okay? Because I go into great detail on that. So I get 36.373, etc. grams, okay? And now let's look at B, and we need to get its x and y components here, okay? So here is B sub x. There's B sub y. This angle is 20. Notice how the opposite of this angle is x. Over here, the opposite was the y, so it's really important that you draw these triangles and you look at where the angles are at, because it's not always sine associated with y. In this case, sine is associated with x, and cosine is associated with y. So the magnitude of this vector is 18 grams. So B sub y, we're going to use cosine because it's adjacent. So that'll be 18 grams cosine 20. So 18 times by the cosine 20, and that gives us 16.9145, okay? And then we want our x component here, so that would be B sub x is equal to 18 sine 20. Okay, and that gives us 6.1563, etc. grams. Okay, now, at this point, what I like to do is look at these magnitudes and now determine, are they positive or negative values. So, when I look at A sub y is in the positive y, so that one's good. A sub x is in the positive x, so that one's good. B sub y is in the positive y, so that one's good. But see how B sub x is in the negative x direction? So now I'm going to throw that negative sign on there, okay? Because it's in the negative x direction, that component is. Alright, so we've figured out each component here. We said A sub y is 21 grams, and A sub x is 36.37, I think it was 3 grams. B sub x was a negative 6.15 grams, and then B sub y was 16.9145 grams. Okay. So let's remind ourselves, A plus B, or the resultant of that, C, is going to be AX plus BX, okay, and then AY plus BY. So A plus B, or the resultant, which we will call C, and that's going to equal there we go. That's going to equal A sub x, which we already know is 36.373 grams, plus B sub x, which is negative 6.15 grams. And then we're going to take A sub y, which is 21 grams, plus B sub y, which is 16.9145 grams. Okay, so C, resultant vector C, I'm going to add these two values. Okay, so I'm going to take my 36 number and I'm going to add that to that negative 6.15 number, and I'm getting 30.21. Okay, so that's our x component there. And then we have a y component, which is going to be this 21 plus the 16 value. Which is 37.915. Maybe, yeah. What I'm saying here is if I'm looking at the resultant, when we're adding a plus b, we're going to call that resultant c. And this 30.21, that is cx, that's the x component of it, and this 37 is the y component. Okay, so that's the vector addition to get this x component and to get that y component there. Okay. Now let me read through. Yeah. No, I think that's where it was going. From here, you may be asked, what is the magnitude of this c vector? And I want you to be really careful with this, because it's not just this number plus that number. Like if I were to draw c, like we'll just say, okay, we have this great resultant vector, and it's, you know, something like this. Okay, and so we're calling that our c vector, and we have c sub x plus our c sub y. Okay, and see, we're dealing with another right triangle, and then you're going to go back to Pythagorean Theorem. Okay, you're going to say a squared plus b squared equals c squared, or cx squared plus cy squared equals c squared, or c is equal to the square root of cx squared plus cy squared. Okay, and we know those numbers, so we can plug those in. We can take the square root of 30.21 squared plus 37.915 squared. Okay. So I plug that in my calculator. Square root, the 30 value squared plus the 37 value squared. And I get a final number of 48.48 grams. Okay, so remember these were all grams. Okay. There's the magnitude, and there's the x and y component of that. Sig Figs. Sig Figs get very, very complicated very quickly with these types of problems. So on your exam and on your assignments and things, when we're encountering something just like this, your answer should be between 3 to 5 Sig Figs. Okay, so I left it with 4 Sig Figs at the end there. All right. When we come back, we have a couple of example problems. Like, we have quite a few example problems. I'm not going to be doing every single one of them, but I am going to do a few of them. So when you come back for the next video, that's what we'll be working on.